So the next speaker is Kate. Hi, Kate. I will do a short introduction
Hello.
of Kate.
Is it okay? Can you hear me?
Yes, yes.
Okay.
So I do a short bio introduction, Kate. Okay. So yeah, Kate is a fellow of the Institute of Actuaries and has provided actual consulting service to both corporate and reinsurance clients. And she is also a member of the Data Analytics Committee of Singapore. Yes. And today she's going to talk about a topic that was done by one of the task force of the committee about the land transport authority, some data that can be taken from them, and for some data visualization. Okay, the floor is yours.
Okay, so I'm gonna share my presentation. It's all good. It's all sharing, right? So shall I start?
Yeah, I think it's fine. We can see on the left the you know, like the scroll small. I think it's fine. Go ahead. Yes.
Okay. Hi everybody. This is Kate CHEN. Thank you for this opportunity to present to you guys through Zoom. I'm the head of actuarial for Dr. Re Asia. So we're pretty new here. Started late this year. So many of you guys might not have heard of our name, but we're just trying to present more and get our names out there. So today I'm going to talk about the data visualization project we did within our data analytics committee of SAS. So basically, I think today this is less of any commercial use, but more dive into how we collect the data, how we view the data, and how we actually try to visualize the data. This actually gives us a quite good opportunity to look at what kind of data the Singapore government is actually collecting and also providing to the public, of course, for free. So before this whole project started, I think in 2018, we even didn't know, but I think I even didn't know, there's a bunch of really rich amount of data that government's already collecting and providing to the public. So today I'm going to dive into what kind of data the government's actually providing to us and what types of data there are, and also from actuarial point of view, how to collect this data and what are the potential usage or next steps for us once we collect the data, what kind of use that we can get out of it. So basically, this whole data collection or providing the data by the government is actually from the initiative of a smart nation. So the smart nation basically talk about economy, government, society, so all on digitalized. So basically what that means is they wanted to make sure that all the economy is turning on digital, especially now we're going through a pandemic, that everybody is actually working from home and some business is running online. So that actually proves economy, digital economy is way more important than any other time before. And digital government is actually essentially looking at putting in all the data in the clouds or in a storage open to people for analyzing or for academic use and to improve citizens' daily life. And society digital to make sure everybody is in the heart of this whole digitalization process and actually make use of all the data shared and also the results are from the whole process of digitalization. So basically, if we look at this on the government, it's actually on the data.sg.government. If you haven't or never look at this website, I would recommend you, because I think majority of people who are listening to today are actuaries or who are interested in data analytics. So I would recommend you go to this data.sg.government. So then if you go to here, then you can see there are 9 topics. And also, according to the government, there's 1,884 data sets, and counting that actually collecting all the data according to the different topics. If you click in one topic, you can see all the data they've been collecting. So down below, you can see some of the charts and bars. So these are the data built, charts actually built on static data. So that means the data is actually collected, I think, not so frequently, for example, per year, per quarter, then it's all fixed and stored somewhere. So if you just go to the government data.government.sg, you can just download that static data. So that's already stored there. Potentially not the most updated data set, but then you can have a look at, what they look at, or any other previous trends that it represents. And on the left, it's actually quite interesting. That's quite closer to what we wanted to present today on the transportation. So on the right, if we go into the website, you can see the real-time taxi availability at a glance at key hubs. So this one, comparison to this one, is actually, this one's on live. So every single minute you go there, that will change. Depends on how many taxis are available at each station and location. So if you go in there, I just grabbed it, I think a couple of days ago, of a screenshot. So then you can see the how many taxis around different hubs here. And then according to the data sets, all the hired and busy taxis are all excluded. So these kind of data sets are quite useful for people's day-to-day making decisions, for example, planning a route, or looking at when or where to take taxi. So then today I'm just going to talk about what the committee and us, we've been working on for the past, I think, a year plus. So that's all we look at the transportation data. So of course, that's all provided by the LTA, the Land Transportation Authority. So then if you go to LTA, so there's a subset in LTA's website called Data Mall. So actually this part of data is one portion of the overall data provided by the Singapore government. And as I just mentioned, there are mainly two types of data. It's not really exclusively unique as Singapore government's data. It's all kinds of data available in the whole world, and basically are two types. The one is static data, the other is real-time data, or we call it as dynamic data. So static data, I think majority of us for traditional actuaries, we work with static data pretty much every day. You look at a claims account, claim counts, claim amounts, premiums, all these. You notice that these data are all collected and stored and recorded, like 3 months ago, 1 year ago, they use that for your pricing, for your analysis work. So similarly, in that LTA data model, there's this kind of data, public transport and geospatial. So that means basically just the longitude and altitude of the key locations or bus stops that you can refer to, and facts and figures. Actually, I plotted some charts based on the static data. I will show you guys in a minute. Then for real-time data, we're looking at traffic incidents. This is actually our focus for our data analytics committee. I'll dive into that in a minute as well. And then roadworks, estimated travel times, bus arrival, and passenger volume. So basically these data are all real time. So that means if you call, basically you request the data as at now, then you will get the as at now, the actual time, actual update on this kind of data. So all these data in two categories, the data sets are all provided by the LTA through its land transport data model. So I'll just briefly mention about what static data is. So basically static data is fixed data sets, not updated after recorded, and really just readily stored in the formats and easy to get access to. So these are the formats actually the government's providing for the static data. So that's CSV, Excel, and PDF. I think all of us were pretty familiar with all these types of data formats. And so as actually how do we analyze these kind of data, we're very much familiar with that. So basically we just download the data set, then we start basically putting in the data set in Excel, start analyzing. And I mean, for some fancier actuaries may just use R to analyze the data, but still the basic of the data is all static. So that means it's all fixed. So it's really good for observing trends represented by data, maybe for the past year, maybe for the past quarter and such. So I did some charts based on some of the static data sets. So for example, we can see the public transportation kilometers traveled throughout the years. So you can see for this data set, it's actually last updated is in 2014. So it's not that as useful as we want to see, because we're now in 2020 already. And this has the new cars by make. So this one, I think, is updated by this year. So you can see different kinds of cars, how much in proportion is per different make. And then this one's quite useful as well. So it's the motor vehicle population. So we can see how many citizens actually hop on a bus, hop on a taxi, or private hire bus during the past year. So we can actually highlighted the trend going down here because that's all the pandemic happens and we had the circuit breaker. So potentially there are fewer people actually went outside and took any transportation. So this geospatial information, as I mentioned, basically just a whole map with the longitude and altitudes of for the key locations in Singapore. So, and then for the dynamic data processing, so basically, as I just mentioned, it is just a constant flow information that it gets updated at any time. So for example, for the traffic incident information that gets updated every 2 minutes. So for example, you imagine there's a data flow. So if every time you go to the data flow, you wait for 1 minute or 2 minutes, there's an update. Will tell you whether there's an accident happened and somewhere. So then if you go there again, you will get a new data. So every time you go there, you update, refresh that data set or request an incident report, then that will get it to you. So the question, I mean, for actuaries, we wanted to see the whole data set. We don't want to see 1 or 2 single record. So how do we do that? Because this whole data set is not stored, it's not readily available. The information is updated instantly. So how do we do that? So basic instinct tells us if we can have a computer sitting here and the government's data sets over there is updating every day, 24 hours, then we have a computer sitting here and calling the data from this data center, then that should work. So that should be the basic way to do it. But is there any better ways? So this is basically what, I mean, for the actuaries with data scientists in heart that we wanted to solve it. So naturally we think about cloud. So cloud means that if I turn off my computer, if I just run something in the cloud, or I have my code actually running in a terminal who's actually built up by the cloud, then that means I don't need a computer to be on 24/7, but still collecting the data because that's the scripts are running in the cloud and then talking to the government's data set. Or what we're looking at here is the Raspberry. So basically Raspberry is a really cheap PC kind of computer. It doesn't have any keyboard, doesn't have any mouse, but you can just buy a Raspberry for $200, and then you can have this kind of PC on for 24/7 hours. Then you run your script on and on again to collect the data collect the dynamic data and then store it in Raspberry or in your own storage, like in a USB or any hard drive. So how do we do it? So basically, there is a data stored in a government agency, basically in a data.government.sg. Then there is an API key. So basically, you have to sign up on the data mall to obtain the authorization key and unique user ID. So the government wanted to know who's requesting this data, because if the website cannot entertain so many people requesting at one time, they will break down. So basically that sounds like a massive attack. So we wanted to control how many people requesting for the data, and then they wanted to know who you are. So this is API is actually not too new to many of us, but just a brief recap on what API is. So API is you can think about like a menu. So you wanted to order something. So you wanted to talk to the chef, to the restaurant, what you want to order, then you want to get your dish. So API is a whole menu. So you just select from the menu what you wanted to order. Then the waiter will just send over. So waiter is your script. With your script, that will send over to the government data site, then to extract the data you want. and to actually pass or to formulate it in the format that you want. So you basically, you are here just to collecting whatever you requested. So API is doing the work. But to make sure that the government know who's requesting for this kind of dish, then you wanted to identify yourself here. So here is you requesting the data real time, and then you running the script on the cloud, because you don't want your computer to up 24/7 and nonstop. So you have your script actually running in the cloud. There's many ways to do it, depends on what kind of language or what kind of system you're on. So you need a package or a script to run, actually to tell the terminal in there to actually execute your script by, for example, every 5 minutes, and also keep the data stored in the cloud. So after a period of time, then you have enough data stored in the cloud, then you need another line of script just to download the data to your local computer. So that's the whole process of it. Then this, what I talk about, the obtaining data, then in the end, it's just check and cleanse the data. So this part is actually what we are more familiarized with. So that's just, you look at the data set, potentially in CSV file type. Then you check on the data, see if that's okay, then you can do the further cleaning on the data. So this is the whole process. So this part is actually the most, how do I say, different part to how we deal or analyze static data. Because for static data, we actually starting from here. We just obtain the data set in Excel or in PDF, and then we start checking and cleansing the data. But then for the real-time dynamic data processing, then we need some so-called data crawling or data scraping. So basically, you want to scrape kind of data on the website instantly and then store somewhere. So this is the extra step we're going through. But actually obtaining the unique API key or use the API, make API calls, this is relatively straightforward, because for every single API or for every restaurant, they will tell you how to order, right? So if you go to the data mall, they will tell you what kind of script that you should use, what kind of API URL, that's the website or the link you should use in your script to obtain the data. So this part is relatively easy. And real time is basically, I just state what the feature the data is. And the cloud computing, even though I didn't include the cloud computing here in the presentation, but it's relatively quite, I mean, it's somehow new to me before I started looking at this project as well. So basically cloud computing that you can look at, for example, there's the cloud by Google, there's cloud by Amazon. Many of the developers, they actually use Amazon as their cloud. And there are some small enterprises or small business that all use Amazon cloud as well. So basically, how do you use Amazon cloud is you register yourself with Amazon and saying, I want to use your cloud computing service. That means you reserve, for example, a storage on Amazon's cloud. So that means if you have any data, you can just put the data there. So this kind of storage is called bucket. So the bucket is quite a common name for any part that you wanted to store the data in the cloud. So there is a bucket in Google, there's a bucket in Amazon. So you have the bucket here. And the second part is you need to run your script in the cloud. As I said, you don't want your computer to be up 24/7, but you wanted the script to be called time and time again to extract the data from the government's website or government's data sets. So you need to rent or instance. So that means there is a terminal that provided by Amazon. Then you can put your script there to have it run it, and then save the data in your bucket. And the bucket is on the Amazon cloud. So the obtaining data, as I just mentioned, basically just you need to write one line of code, which is already provided by Amazon as well. So there's every single step in how to use this cloud and how to access to the data, how to call the data, and then how to download the data. It's all presented in their statement once you wanted to use it. So just another additional comment on it is basically for Amazon, there is a free tier care of using its cloud service or using its instance. So basically use the terminal to run your script. So if everybody or anybody interested, you can just go to the government website, look at what kind of the real-time data you're interested in, and obtain the API and register yourself here and obtain the codes and how to talk to the API and extract the government's data. And then register yourself with Amazon to start with cloud computing, basically. That's the basic steps with any cloud computing. Then you can start collecting your data right away. So here I just show what the LTA traffic incidence data look like in the raw form. So basically that's just in the CSV form. So there's a type of incidence, there's longitude, altitude, so that represents where the incident is. And there's time, so to what time it happened, and then description. So basically it's all basically in 1 or 2 cells with no separations. Then when we did sanitize data, basically just put in different columns. So make sure it look okay, check on the information. So just do a simple data checks. For example, look at longitude, altitude is all looking good. And look at the time is at the time interval that we set to collect the data. So if that's all okay, then that's done. So that's the data collection part. So here I just mentioned what the data include, all the types of data. That's basically this types of data includes here is all provided by the government by the category. And then for the plotting on the traffic incidence data on the Singapore map, I think Jack has did a quite good job. And he actually found out there's a package called volume. So basically there's a volume in the Python library. Then that utilizes the open map. So basically you will tell this library to plot a map as your base map. So basically you imagine that's a canvas for you to actually overlay your traffic information, because there's longitude, altitude in the traffic information we just saw. And then once you overlay that Singapore map, here is the base map. Then with the traffic information here, then all the dots actually marked as what are the incidents happened previously and where they are. So yeah, I think that's a quite interesting experience for me and for our data analytics community group as well. So basically look at all the data sets in the traffic data set, for example, and also there are other potentials and opportunity for us just to analyze the data, and especially with the real-time data set, because there's no stored, for example, incidence data provided by the government, except for this real-time 2-minute update data that provided to the public for people who have the ability to extract and store the data. So I think I also saw some examples that people did with the other LTA data set. Basically, it extracts the bus arrival time. So basically look at this arrival time or passenger volume. Then this person, I think, who is also a programmer, what he did is he derived his own way of calculating what's the best route for him to for everyday commute. So that's all entirely based on the API here and the data he collected from here. So yeah, I think there are many other use for the data we can collect from the government for the data model. So, I mean, I think for our actuaries, we're pretty familiar and comfortable with the static data. So, I mean, for us, maybe just push the boundary a little bit, start looking at the real-time data. I think that might be something interesting that we wanted to get crack on with just a few lines of code, and then we can get started and also have a feel of what actually cloud computing is, just through this really small project we've done here. We're happy to share this presentation or the code or our thinking process with the fellow actuaries who are interested. So, and also we might work on for the projects. For example, previously we wanted just to look at the weather data as well, to overlay, for example, the weather on the marker as well, to make sure, basically to dive into, is there any correlation between severe weather happened and also some really bad incidents happened all over the whole Singapore. But yeah, so this could be an ongoing project for us, and yeah, we're happy for other actors to jump in and work together with us on this. So this is all my presentation. Fred?
Thanks, Kate. Yes, we welcome any volunteer who wants to join the data analytic committee. So there is a question, Kate. So maybe I just read the question. Okay. So many small questions in one big question. So which tool do you use for visualization? That will be the first one.
Okay, shall I answer now? So the tool we used is a library in Python called Volume. So that one has the ability to produce the base map. So basically you input in a longitude, altitude, for example, for your city or for your country. I mean, for Singapore, because it's quite small. So basically you input the longitude, altitude, then that will show the whole Singapore Singapore map. And then from that, with the overlay of longitude, altitude, the traffic incidents, then we can just do the visualization here. Then for the presentation purpose, there are two ways, because right now I think we used Google Colab online. So that in that way, then this whole visualization or interactive thing will be represented online in web. But another way, then I think simpler way is really just do it in a terminal. For example, in Python terminal, then we can just show the whole visualization as well, but might not just be presentation purpose, because for presentation, I think HTML or web page is better. So that's why the Google Colab is used. Another way is you can consider Jupyter as well. So that can also render the typical Python program or code.
Okay, then there is another question regarding graphs. If you have, what do you think of graphs? So some example, Tableau or SAS.
I think Tableau is quite good. I mean, for starters, because Tableau's already got the ability to cleanse the data and to basically mapping the data as long as there's longitude and altitude in the data set. And R is quite useful and relatively easy to learn as well, especially now you can do R programming in RStudio, which has a better coding or programming experience. SAS, I haven't used SAS for the maps or for visualization, but I think SAS is quite a basic data analytics tool as well. So I think for starters, I think Tableau is good. R is good too, but considering Tableau is actually not free, so I think R might be better because R is just free to use anyways.
Thank you. And then the last question, I really don't know if you know how to answer that. How to efficiently represent a 5-dimension in a chart or in a video?
I'm not quite sure of 5-dimension. I think that depends on, for example, for the library you use to lay out the map or to overlay, for example, traffic incidents, or we're just talking about a map. That depends on if there are enough arguments in the package that allow you to actually shift or change how you represent the map. So basically in this volume, this package, we used, you can see the black and white, the high contrast. This actually by the argument that we chose just to show the river, the ports, and also the terrain here. So there are other arguments that can be used. I mean, potentially can show more. For example, by the different district, there are different colors you can assign to, or different allocation, and there's a different shades of color to assign to. But for 3D or anything, I haven't tried yet. I'm not quite sure if this one can produce, I mean, basically above 3 dimensions.
Okay, thank you, Kate. There is no other